rectangles, rhombi, and squares. So in the first blank, we need to fill in the blank with rectangle. So a rectangle is a quadrilateral with 4 right angles. And just in case you forgot, here's a picture down here of a rectangle. Notice in the corners, all 4 of those are right angles. And then it tells us that a rectangle is a special type of parallelogram. So it has all the properties of a parallelogram. So a rectangle is a parallelogram because the opposite sides are parallel. Okay, so since a rectangle is a parallelogram, it does inherit all 5 properties of a parallelogram. So we are going to fill in these properties, same properties we've seen the last 2 days. So the first property of a parallelogram is that opposite sides are parallel. I'm going to abbreviate. Opposite sides are parallel. So if you want to mark it, we know that the top and bottom are parallel. The left side and the right side are also parallel. Property number 2 of a parallelogram is that the opposite sides are congruent. Opposite sides are congruent. So if I mark my diagram, that means that the top side is congruent to the bottom side, and the left side is congruent to the right side. Property number 3, opposite angles are congruent. We talked about the opposite angles being diagonal from one another, so that means angle B and angle D are congruent, and angle A and angle C are also congruent. Property number 4, since we do have parallel sides, then the same side interior angles are supplementary. Same side interior angles are supplementary. What does supplementary mean? As to equal 180. And then the 5th property about parallelograms is about the diagonals. Do you remember the property about the diagonals?
Oh, they're bisect?
Yes, the diagonals bisect each other. Fancy, freezing on me. Diagonals bisect each other. Okay, so since a rectangle is a parallelogram that has all 5 of those properties we've seen the last 2 days. Then, since it is a rectangle, it does have some special properties, and we are going to add that here in just a moment, but we have another dialog box here that we need to fill in. So here's the theorem. If our quadrilateral is a rectangle, then the diagonals are congruent. So in a rectangle, the diagonals are congruent. So BD is congruent to AC. So for the conclusion, we need to write down that the diagonals are congruent. So the diagonal BD is congruent to the second diagonal, AC. So in a rectangle, the diagonals are congruent. Okay, so 6 and 7 are going to be the properties that are specific only to rectangles. And for the rectangles, we know that in order for a quadrilateral to be a rectangle, you have to have 4 right angles. And those 4 right angles are at the corner. So in order for a quadrilateral to be a rectangle, you have to have 4 right angles at the corner. And if you notice this diagram up here, we have a right angle at A, B, C, and D. So A, B, C, D is a rectangle because it has 4 right angles at the corner. And then the second distinction about rectangles is what we just saw in this text box, that the diagonals are congruent. So in a rectangle, the diagonals are congruent. And since a rectangle is also a parallelogram, the diagonals also bisect each other. So it has 2 properties about the diagonals. So the diagonals bisect each other, and they are also congruent to each other. Okay, so example 1, it says that the rectangular gate has diagonal braces. Find each length. So we want to find the length HJ. So HJ is the top side. So if the bottom of the rectangle is 48 inches, what is the top of the rectangle going to be? 48 inches. So HJ is 48 inches. Question B, we want to find the length of HK. HK, H to K, they're asking for the length of this diagonal. And property number, I think it was 7? Yeah, here it is, 7. It tells us that the diagonals are what? Congruent. So I first need to find the length of diagonal GJ, then it will be the same length as the second diagonal, HK. So on the other diagonal, they have this piece marked as 30.8. And since a rectangle is a parallelogram, we know that the diagonals bisect each other. What does bisect mean? Cut in half. So the top half of the diagonal is 30.8. What is the bottom half of the diagonal? 30.8. So to find the entire length of the diagonal, we need to add 30.8 and 30.8. And what is the total length of the diagonal? 61.6 inches. So if this diagonal is 61.6 inches, the second diagonal is congruent to it, so both diagonals are 61.6 inches. Easy, right? Good. Okay, moving on to a rhombus. Remember, the plural form of a rhombus is rhombi. We don't say rhombuses. Rhombuses. We say rhombus. Okay, so this would be a rhombus. Rhombus. Let me fix that each. quadrilateral to be a rhombus, you have to have four sides that are congruent. So that means a square is also called a rhombus, because does a square have four congruent sides? Yes, so a square is also considered a rhombus. But most of the time, the rhombus is not up and down like a square. It's kind of being slanted a little bit. So most of the time, a rhombus is a little bit slanted. It's not square-like. Next one says that a rhombus is a special type of parallelogram. So a rhombus is also a parallelogram. So it still has all those properties about a parallelogram. That the opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, same side interior angles are supplementary, and the diagonals bisect each other. So a rhombus is a parallelogram, so it has all the properties of a parallelogram, and it has some properties of its own. So here's some properties that are special about a rhombus. So these two properties are for rhombuses. Let's put them on by that. Okay, so if a quadrilateral is a rhombus, that means that the diagonals are, what does this symbol mean right here? Perpendicular. So if you forgot that this symbol means perpendicular, that symbol means perpendicular. So in a rhombus, the diagonals are perpendicular. So looking at this diagram, if the diagonals are perpendicular, that means BD is perpendicular to AC. So for the conclusion, we're going to say that BD is perpendicular to AC. And if two lines are perpendicular, that means that they meet at what type of angle? 90 degrees. So all four angles in the center are 90 degrees. So if your diagonals are perpendicular, that means all four of these angles in the center are 90-degree angles. They're all right angles. And then the second property about a rhombus, if a quadrilateral is a rhombus, then the diagonals bisect opposite angles. What does bisect mean? Cuts it in half. So the first property comes from the parallelogram property. We know that since a rhombus is a parallelogram, the opposite angles are what? Congruent. That was property number 3 that we wrote down at the very beginning. So if the opposite angles are congruent and the diagonals bisect them, what does bisect mean? Cuts it in half. So if angle A and C are congruent, and they are both cut in half, that means all four of these halves are congruent. So that means angle 8, angle 7, angle 3, and angle 4 are all congruent. Opposite angles are congruent. So we start out with angles that are congruent, and then we cut congruent angles in half. So all four halves are congruent. So to write that, I'm going to say that angle 3 is congruent to angle 4, which is congruent to angle 7, which is congruent to angle 8. So 3, 4, 7, and 8. Same thing for the other diagonal. Opposite angles are congruent, and then these congruent angles are also cut in half, so these four angles in red are also congruent. So that would be angle 1 is congruent to angle 2, which is congruent to angles 5 and 6. That's congruent to angle 5, which is congruent to angle 6. Okay, right below this dialog box, we are going to write all three properties that are special for a rhombus. So a rhombus has four congruent sides. the square is also called a rhombus, because the square has 4 congruent sides. And the other two properties come from this text box right above it, and the first one is that the diagonals are perpendicular. And since those diagonals are perpendicular, that means we have 90-degree angle at the corner, not at the corners, at the center. So right here in the center, all 4 of these angles in the center are 90 degrees. So if it's perpendicular, they intersect at 90-degree angles. Property number 8 also comes from this text box, so that bottom row of that text box says that the diagonals bisect opposite angles. So the diagonals bisect opposite Wow, dude, it's not funny. 3/4 of the way, 1/4 left to go. Can I switch to the next page? Okay, now we have some examples. It says example 2, RSTV is a rhombus, so that means all 4 sides are congruent. That means the diagonals are perpendicular, and the diagonals also bisect the opposite angles. So it's a rhombus. Find each measure. Let's see. Property number 2 is that the diagonals are perpendicular. So if these 2 diagonals are perpendicular, then they meet at what type of angle in the center? 90 degrees. So I know this angle should be 90 degrees. So what I'm going to do over here, I'm just going to set that equal to 90. So all 4 angles in the middle are 90 degrees because the diagonals are perpendicular. Solve that for y. Subtract 10 to both sides. So that gives me 2y equals what's 90 minus 10? 80. Divide both sides by 2. What does y equal? 40. Did they ask me for y? No, I didn't even look to see what they asked me for. I just didn't puzzle them. Oh, what have we done yet? They want us to find the measure of angle WSR. WSR is this angle right here. And these 2 angles, what do we know about these angles and the diagonal? Let me go back to the properties. Yeah, it says that the diagonals bisect the opposite angle. So if this angle is y plus 2, then WSR was bisected, so it's also y plus 2. So these 2 angles, even though this is marked as the top angle, WST, these 2 were bisected, so these 2 are equal. So I'm going to use the y plus 2 to solve. So if the measure of angle WSR is equal to y plus 2, what do I put for y? 40. And what's 40 plus 2? 42. So the measure of that angle is 42 degrees. So the diagonal bisects those angles. Okay, and the last one for today is a square. So the first one is square. So a square congruent sides. So if it has 4 right angles, that means it's a rectangle. If it has 4 congruent sides, that means it's a rhombus. So the next part says that a square is a rectangle because it has 4 right angles. It is a rhombus because it has 4 congruent sides. And there's one more feature that it falls under. It's also a parallelogram. And it's also a parallelogram because we know that the top and bottom are parallel, and the left side and right side are parallel. So squares have all of those properties. It has the 5 properties from the parallelogram, it has all the properties from the rhombus, and it has all the properties from the rectangle as well. So, example 3, they want us to just dive in. We already know all the properties now. And it says put all segment measures on this square. So that's example 3. I guess this one's called number 1. Since over here, this one's called number 2. Okay, so they tell us this is a square. Got this random stuff down here. Let me erase that. Okay, so since this is a square, what do I know about the side lengths of all squares? They're congruent. So the left side is 8, the top side is 8, right side is 8, bottom side is 8. So that is pretty easy so far, right? And I know what kind of angle do I have down here in the bottom? 90-degree angle. What do you notice about these 2 legs? They're congruent, so if those 2 legs are congruent, that means that these angles are congruent. So half of 90 degrees would be 45 degrees. And on our last unit with SOHCAHTOA, we had that formula sheet for the 45, 45, 90 triangle. And off of that formula sheet, we said that the legs were x, and the hypotenuse is x square root of 2. So on my 45, 45, 90 triangle, if my 2 legs are 8, so we have 8 and 8, what would that hypotenuse be? 8 square root of 2. So the hypotenuse of that right triangle is the diagonal. So down here I'm going to write that the diagonal is equal to 8 square root of 2. But the diagonal is split up. What do I know about the diagonals for parallelograms? They bisect each other. So if the whole diagonal is 8 square root of 2, I need to cut it in half. So what's half of 8 square root of 2? 4 square root of 2. So that means this piece is 4 square root of 2. This piece is 4 square root of 2. This piece is 4 square root of 2, because the square is also a rectangle, so that means that the diagonals are congruent. And this one is also 4 square root of 2. Okay, so we got all of the sides marked up, so we're done with that one. Now for this next one, problem number 2 says put all angles on this square. Well, if it's a rhombus, what do I know about the diagonals? They're congruent. They bisect each other, and one more thing. They meet at a 90-degree angle. Because since the square is a rhombus, the diagonals are perpendicular. So if they're perpendicular, that means this is 90 degrees. This is 90 degrees. This one is 90 degrees, and this one is 90 degrees. So all of those angles at the center are 90 degrees. And then we know that the diagonals bisect the opposite angles. So if the diagonals bisect the opposite angles, well, first of all, what is this entire angle down here at the bottom? 90, and if the diagonal bisects it, what's half of 90? 45. So all of these angles are 45. So half of 90 up here is also 45. Over here in the top right, half of 90 is also 45. Down here in the bottom, half of 90 is also 45. Okay, guys, practice. It says a woodworker constructs a rectangular picture frame so that JK is 50 centimeters. JL is 86 centimeters, so JL is going to be the diagonal. And what do we know about diagonals of parallelograms? They bisect each other. So if the whole diagonal is 86, then what bisect means? Cut it in half. So if I take 86 and cut it in half, what is each half of the diagonal? 43. This one's also 43. And in a rectangle, what do we know about the diagonals? They're congruent. So if these two halves are 43, these two halves are also 43. Because this diagonal is also 86. And if the left side is 50, what's the right side over here? 50. Let's see what we have to find. Find the measure. So number one, we want HM. Have we already found it? Yes, HM is half of a diagonal, and half of a diagonal is 43 centimeters. Number two, we need to find KL. KL is the top. Do we have the top? No. But what we could use is a right triangle. So I'm going to make a right triangle in blue. And we're looking for KL, so I'm going to call that one X. The Pythagorean theorem is C squared equals A squared plus B squared. C is the hypotenuse, so the hypotenuse is that diagonal. And what's the length of the diagonal? 86. So this would be 86 squared. Equals the two legs are 50 and X. So this would be 50 squared plus X squared. What is 86 squared? 7,396. That equals, what is 50 squared? 2,500 plus X squared. Get rid of the 2,500. How do we get rid of the 2,500? Subtract the 2,500 to both sides. What is 7,396 minus 2,500? 4,896 equals X squared. The opposite of squaring? Square root it. This one's not a perfect square. They set you round to the nearest centimeter. So to the nearest whole number, square root of 4896. So control X squared, 4896. And what would that be to the nearest whole number? 70 centimeters. Next one, use the rhombus to find the numbered angles. The measure of angle BCD is 108 degrees. So BCD is this entire angle is 108. Properties about rhombus. A rhombus has four sides that are congruent. the diagonals are perpendicular. So if the diagonals are perpendicular, what is the measure of angle 2? If they're perpendicular, what types of angles do we have in the middle? 90 degrees. So angle 2 is 90 degrees. And there's one more property we're going to have to use from the rhombus family. And for the rhombus, what does this one say down here? The diagonals bisect the opposite angle. So we're going to use that with the 108 that they gave us. So the diagonal bisects this angle. What does bisect mean? Cuts it in half. So if that whole angle is 108, what's half of 108?
54.
So angle 3 is 54 degrees. This angle beside it is also 54. So angle 3 is 54 degrees. And if I know that it's a rhombus, that means it's also a parallelogram. So that means the top and bottom sides are parallel. And if this angle is if angle 3 is 54, then the alternate interior angle is also what? 54. So if angle 3 is 54 degrees, angle 1 is also 54 degrees. And since these lines are parallel, the top side and the bottom side are parallel, that means our same side interior angles add to what? 180. So I need to do 180 minus 108. And what's the top angle going to be? 72 degrees. So this entire top angle is 72 degrees. And I know that the diagonal does what with that angle? Bisects it, so it's half of 72 degrees. So angle 4 is 36 degrees. Angle 5 is also 36 degrees. So angles 4 and 5 are both 36 degrees. This next one, ABCD, is a rhombus. Find each measure. So on a rhombus, what do we know about the diagonals for a rhombus? That's for a rectangle. They bisect opposite angles, and one more thing about the diagonals. They're perpendicular. So if the diagonals are perpendicular, then what is this angle right here? 90 degrees. So I'm going to say that 12y equals 90 degrees. Divide both sides by 12. What does y equal? 7.5. Okay, so we found y. We're going to say that for a few minutes. Let's find x. What do I know about the side length of a rhombus? They're congruent. On a rhombus, it has 4 congruent sides. So that means this top side and the right side are congruent, as well as the other 2 sides. So if the top and right side are congruent, I'm going to set these equal. So 4x plus 15 equals, the right side is 7x plus 2. X is on both sides. Should I move the 4x or the 7x? 4x. So that gives me 15 equals 7x minus 4x is 3x plus 2. What's next? Subtract 2 to both sides. 15 minus 2 is 13 equals 3x. Divide both sides by 3. I'm going to leave this in fractional form. I'm not going to round my answer until the very end, because this one is not a nice, even decimal. Like this one was 7.5, that's called a terminating decimal. This is called a repeating decimal, so I don't want to leave it as repeating. So just leave it as a fraction for now. Okay, so number 4 asks us for AB. AB is one of the sides. So do they have it marked? No, so I could use either one of these. I could use the 4x plus 15 or the 7x plus 2. Which one do you want to use? 7x plus 2. So this one is equal to 7x plus 2. Instead of x, what do I put for x? For x, we do 13/3. Plus 2. We have a fancy calculator. I'm going to use it. I'm going to do 7 times, control divide, 13/3 plus 2. And what do we get for that one? 32.3 repeating. 32.3 repeating. And right now, since that's my final answer, now it's okay to go ahead and put the repeating decimal. I just wanted to round at the very end. I didn't want to use a rounded answer to try to find the final answer. Then number 5, we want the measure of angle ACB. ACB is this angle up here. Oh, it's already marked for me, which is 4y minus 1. And instead of y, what number do I put for y? 7.5. So we need to do 4 times 7.5 minus 1. So 4 times 7.5 minus 1. That answer is 29 degrees. Okay, line 2, find the measures of the numbered angles in each figure. And number 6, they tell us it is a rhombus. So a rhombus, what do I know about the diagonals in a rhombus? They bisect the opposite angles, they bisect each other, and one more thing for a rhombus. They are perpendicular, so that means angle 4 is what angle? 90 degrees, so angle 4 is 90 degrees. A rhombus is also a parallelogram, so I can use alternate interior angles. So if this angle is 26, what is angle 3? 26. And you already said that the diagonals bisect the angle, so if this one's 26, then this one is also 26. And if I add those two together, what is this total angle right here? 26 plus 26 is 52. And I know that this big top angle and this bottom angle are same side interior angles. And what do I know about my same side interior angles? They add to equal 180. So if the top angle is 52, to find the bottom angle, we need to do 180 degrees minus 52 degrees. And what does that give us? 128. But 128 is for the entire angle that was bisected. So we need to cut that in half. And what's half of 128? 64. So that means angle 2 is 64 degrees. Angle 1 is 64 degrees. And then angle 5, what do I know about the opposite angles? They're congruent. So if this one is 64, then angle 5 is also 64. So angle 5 is 64 degrees also. Okay, number 7, we have a rectangle. let's see. I know that the top side and bottom side are parallel because a rectangle is also a parallelogram. So if this angle is 36, then the alternate interior angle is also 36. And in the corners, all of these corner angles are how many degrees? 90. So to find angle 1, I need to do 90 minus 36. 90 minus 36 is 54. So that means angle 1 is 54 degrees. And to quickly find some other angles, I know that a rectangle has lines of symmetry. And I'm going to use a line of symmetry right here down the middle. So let's say I fold that rectangle right down the middle. So if I take the right side and fold it over here to the left side, then it's symmetric. So if this angle is 36, which angle over here is also 36? Angle 2 by symmetry. So angle 2 is 36 degrees. And if I fold it over, the 54 degrees matches up to angle 3. So angle 3 is also 54 degrees. And then we need to find angles 4 and 5. Well, looking at, let me highlight the triangle and look at it. I know that all three angles in a triangle add up to what? 180. So in this blue triangle, I have 36 and 36. So I need to add those two together. So it's 36 plus 36. 72. So I need to do 180 minus 72 to find angle 4. And what is that? 108. So angle 4 is 108 degrees. Angle 4 and angle 5 are called a linear pair. So if they're a linear pair, what do they add up to? 180. So if this one is 108, I need to do 180 minus 108, which gives us 72. So angle 5 is 72 degrees. Okay, the rest of that assignment is yours.